Hey kids, look, doesn't this feel like you're in BC calculus? Separable differential equations. Do you remember that? Again, it's amazing the correlation between what I'm doing now and what I'm doing in calculus. I literally just made a video for BC on separable differential equations. This is really not going to be much different. Hello, gorgeous. I love separable differential equations. So ours is just going to look a little different in that instead of having in calculus, in BC, we usually had something like this. We had dy dx is equal to, I don't know, x squared square root of y is I think one of the examples I just did. So the only difference is here is that we're going to have a differential equation set equal to 0. And it kind of looks like this weird nonsense. So you're like, huh? Well, this is a separable differential equation. Watch the algebra that I do. You see what happened there? I multiplied everybody by dx, right? That's how the dx came there. That's how the dx disappeared there. And of course, since I have 0, that's really nice. Now I am just going to integrate, but integral of a sum is just the sum of the integrals. And of course, integrating 0 is nice. Oops, sorry. So that's the form that we're looking for. So I'm looking for something I can rewrite like this. This looks like a BC calculus example, and it is. Right? Look at what I did. I just multiplied both sides by 1 minus y squared, and then I subtracted x squared. Now, when we were in calc, we left the x squared on the right side, and we just anti-differentiated from there. This is, trust me, going to make a difference later. I multiplied through by dx, and now I'm just going to anti-differentiate. We should put parentheses around there. Right, so x cubed, power up, divide by the power up, 1, y to the first divided by 1, y squared, power up, divide by the power up. Integrating 0, right, is just a constant. Multiplied through by 3 just to make everything nice. Don't really have to do that. And make note from the beginning of any domain restrictions, right? Since my derivative here, my derivative looks like this, I can't plug in 1 or negative 1 in. So how about this one? Okay, maybe you want to pause the video and do this because this one, again, is really very BC calculus-ish. Whoops, sorry. Right, I'm going to multiply by this. By the denominator. Then I'm going to subtract all that nonsense. I don't think I actually want to do that this time. I think I'm just going to BC calculus this and leave it over here. I just need to understand it is separable. Right, so what do I have here? This is just 2y minus 2, so I'm going to integrate both sides with respect to x. So 2y is y squared over 2, cancel the 2's, minus 2y, because that's minus 2, integrating is 2y. Have a constant here is equal to x cubed plus 2x squared plus 2x plus my constant. Plug in my initial conditions, right? Plug in when x is 0, y is negative 1. Zero those out. So c is equal to 3. Therefore, my solution is I don't need to get y by itself. Right? Yay. Right? I told you. Mwah! Love ya. Love ya, separation of separable differential equations. But look at that. What is happening? What is happening? Ah! Can you think of some things to do here? This is highly annoying. But it just takes some algebra. Algebra to the rescue. Check this out. I've got some terms with a y in it, and I've got some terms with no y's in it. So look at the terms with the y in it. Can't I write this as factor out the y, and I get x plus 1, right? Isn't that a way, right, if I use the associative property and I group those two together? And then I can factor out a 2 out of this expression, and I also get an x plus 1. That's called factoring by grouping, kids. And now I have x plus 1 times y plus 2. Oh, Nelly, that's now a product. And again, I kind of hate the whole, I mean, it's nice that it's 0 over here, but I think I'm going to, well, let me leave it like this for right now. Right, so notice that I've still got to collect some things up here. So what if I take this whole situation and move it over here? And you could do either one, obviously. I'm going to move that over there, so I'm going to be left with x squared plus 2x dy is equal to negative x plus 1 times y plus 2 dx. And now I just got to collect stuff around, right? So I want my y's over here and my x's over here, but everything's multiplying. So I can just divide by y plus 2, and even maybe the negative. And then over here, I'm going to have x plus 1 over x squared plus 2x. And now, yes. Hello, separable. Right? Because now I'm just going to anti-differentiate. This is just an ln situation, right? Because that's y plus 2 to the negative 1 with this negative out front. And then what about this? What are you going to have to do with this? Oh, crap. Is this, right, partial fractions? Oh, I would prefer not to do partial fractions. Would U substitution work? What do you think? I have a clue that U substitution might work because I have one group that is a power of 2 in it and one group that has a power of 1. So maybe try. Ah, right. So to integrate this is just going to be the integral of u to the negative 1 du with a 1/2 in front. How do I integrate that? I do want you to get y by itself here. So get rid of that negative. I probably should have left the negative over there to begin with. That's kind of silly. Sometimes I don't see these things till the end. So you're just going to e to the both sides, right? And then we know what the whole idea was with this plus c up there, right? It's going to turn into a multiple. Now I probably could go further with this and get rid of the absolute value and do it, but I'm good. I'm good here. Right, it is tempting because if I take this off and make that the square root, right, of I take that off and then pull up that, I'd have 1 over the square root. So I could do some rewriting with that, but I'm about done at this point, and I'll tell you how far I want you to go. Maybe if my final, match a multiple choice answer or stuff, but this is good enough for me right now. Right? Because the main point of this, the rest of that is just algebra. The main part of this was seeing that I can get back to my old friend separable differential equations from BC calculus, but it might take some manipulative algebra first, right? Because the calculus really wasn't that big of a deal, and there was no initial condition. All right. Well, that's it for remembering separable differential equations and showing you kind of a nasty one to do. And then we're going to, the next lesson that we're going to do during our live session is going to be trying to get ourselves, we're going to be really happy if we can get here. We're going to do some transformations in order to be able to do separable differential equations. That is for our next live session. See you then.